Okay, now let's have a look at the real-world applications of motorway junction designs so that we can better get a feel for how they're used and create more realistic cities as a result. Now, starting off at the very bottom end, you've got diamond interchanges. Cheap to build, very little land take, however low capacity and very difficult to upgrade. The example you're looking at is the M5B4509 junction in the UK. Next up is dumbbell interchanges. These, instead of meeting at crossroads on the slip lanes, meet at roundabouts. Again, only one bridge, and have better capacity than diamond interchanges, but still have the problem of being very difficult to upgrade should the need arise. The example you're looking at is the M5A38 junction, which until recently was one of the next sort I'm going to go into. The next type of junction is a partial cloverleaf, and it gets its name from being kind of like a cloverleaf. Instead of, such as a diamond, the slip roads going off on directionally towards the direction of travel, in a partial cloverleaf they are collapsed in on themselves on one side of the secondary road. Now, functionally they're exactly the same as either diamonds or dumbbell interchanges. You'll find very few partial cloverleafs in the UK that end at a T-junction rather than a roundabout. So they are essentially a kind of dumbbell partial cloverleaf hybrid. The one you're looking at is the M50A38 junction, same A38 as the last in fact, and it's also one of the oldest motorway junctions in the United Kingdom. Round a bit of history for you. Next up is the roundabout interchange. Now these you will find all over the UK, quite a lot in Europe as well, exceptionally rare in North America. Very, very few of them, because Americans get confused by roundabouts, I understand. Anyway, advantages of them: quite cheap to build. The only significant cost is the second bridge. They are quite high capacity, can be relatively easy upgraded to higher capacity junctions in the future, and are very easy to navigate, despite what any Americans might tell you. The main disadvantage of them is they're often used when the funds for a bigger junction aren't available, where they should be, and they get clogged up as a result. Now when these things get jammed, they fail dismally, and that is their biggest significant disadvantage. The one you're looking at is the junction between the M50 and the M5, also in the UK. Next up, starting to get to free-flowing junctions now, is a trumpet interchange. Now, trumpet interchanges are very cheap to build for a free-flowing junction, and they are also quite a cost-effective way of getting traffic off the road into toll booths. You'll find a lot of these in the United States, for example. Disadvantages, though, is they can leave a bit of a big patch of redundant land in the centre of the loop, and they can't scale downwards very well. Because the loop is essentially a 270-degree corner, you have to be reasonably big about it if you want to sustain decent speeds going around it. The example you're looking at is the M5 to A38 and A30 junction, south of Exeter in the United Kingdom. This is where the M5 ends and carries on as two different roads. The next junction type is a directional T. Now these things are very high capacity three-way junctions. They can handle extremely high amounts of traffic with very little problem. They're very easy to use, and the design is actually quite flexible. It's also very easily upgradable as well if future-proofing has been built into the design. However, they are more expensive than trumpets, They are quite difficult to actually build because you've got curved ramps going all over the place. And those are their main disadvantages. The example you're looking at is the M5 M42 junction, just south of Birmingham.